Okay, so we are getting into the exercise questions now. We have this example 4 I'll write. It is like this. Show that relation R not transitive. Okay, now children, they have given the set A. I'll take set A is equal to 1, 2, 3. And they have given R is equal to, it is 1, 1, 2, 2, 3, 3, 1, 2, 2, 3. And now we need to check whether it is reflexive, symmetric or transitive. Let us start one by one. I'll go to the first one, reflexive I'll say. I shall not write any property, but I'll check as it is. Say for reflexive I need the set A, you remember. I'll go to the set A, I have 1, 2, 3. For this to be reflexive, I should have 1, 1, 2, 2, 3, 3. Do I have? See, I have 1, 1, 2, 2, 3, 3. So, I'll say 1, 1, 2, 2, 3, 3. All these belong to the relation R. Therefore, R is reflexive. Therefore, R is reflexive. Next, I'll go for second one. Symmetric relation. For symmetric relation, you don't need the set A, you only need the relation. So go to the relation and inside the relation you check whether for every A, B, ulta BA is there or not. And you need not check for the reflections. For this 1, 1, 2, 2, 3, 3, keep them aside. For 1, 2, I should have had 2, 1. Do you have 2, 1? See, we don't have 2, 1 for 1, 2. For 2, 3, I don't have 3, 2. So we say 1, 2 belongs to R, but 2, 1 does not belong to R. Therefore, R is not symmetric. It is not symmetric. Okay. Next, I'll go to third one, that is transitive relation. Transitive. For transitive, I should have the third pair for every 2 consecutive pairs. That is for AB, BC. You should have AC. Let us check. Again, I need not check for 1, 1, 2, 2, 3, 3. Keep them aside. I have 1, 2, 2, 3. I should have had 1, 3, but I don't have 1, 3 here. So we write the same thing. 1, 2, 2, 3 belongs to R, but 1, 3 does not belong to R. It does not belong to R. Therefore, R is not transitive. So we approved. 1 and 2, 3, these 3 statements tell us that the given relation R is reflexive but is neither symmetric nor transitive. You can declare the answer at the last if you want. But then I would like to tell you one point. If you have to prove yes it is reflexive, yes it is symmetric for any generalized problem, then you have to generalize and write only. You cannot write with 1, 2, 3 example. You should not take your own example and prove. Marks will not be allotted to you. But if you have to tell, yes, it is not reflexive, it is not symmetric. If you want to tell it in a negative way, you can only give one counter example. That's enough. See here, 1, 2 belongs to R, 2, 1 does not belong to R. That one example itself is sufficient for us to tell that yes, R is not symmetric. But in case it is symmetric, you have to tell it in tell orally that for all A belonging to, where is that? For all A here. For all A belonging to the set A comma A belongs to R. You have to tell like this. Now, where am I telling is, when they tell you statement problems, you should not take your own numerical example and start proving the statement problem. You can't do that. You have to take everything in chunky. So, slowly we are reaching that kind of problem. Now, this was a numerical problem. And my point was, whenever you want to tell not reflexive, not symmetric, you can only give one counter example. Even if there are 2, 3 examples, only one counter example is sufficient to tell it is not symmetric or it is not transitive. Let's go to another problem. We have another example problem. This was one of the example problems from your textbook. You have example 5. And this is one of the most repeated questions in exam. So this is one of the very important questions. Example 5, show that the relation 2 divides A minus B. Okay, the most generalized, most popular familiar problem and very important question which occurs for the examination. Now here they are telling 2 divides A minus B. They may tell you 4 divides A minus B, or they may tell A minus B is a multiple of 3, or they may say A plus B is a multiple of 3. See, like this they may give you different statements, and whenever they say such statements with numericals, with the operations, addition, subtraction, multiplication or division, you can not tell the example like say A is equal to 1, 2, 3. You cannot do that. You have to generalize every statement and property. So let us do that. The given, I'll say, given on Z we are taking integers, R is equal to A B such that 2 divides A minus B, and now this is equal to R is equal to AB such that I'll write A minus B is equal to 2m. Okay, 2m or 2k. That will make the job easy for me. I'm writing it as 2m because a minus b is divisible by 2. So I can write a minus b equal to 2 times some other number and I'll call it as m. So I cannot say 2 into 3. I cannot say my own examples 2 comma 4, 3 comma 6 and so on. I cannot do that. So I'll be taking ab only, but only writing 2 divides a minus b as a minus b is equal to 2m, so that I can write it easily. And now I'll come to the first property. Every time you come to the first property, you always remember you are going to use consecutive numbers 1, 2, 3 and the consecutive alphabets R, S and T. So this will be, reflexive relation for all A belonging to the set A. Now of course, okay, let me write the property. A comma A belongs to R. What is the set given to us, children? Our set is integers now. I am taking every element of Z and I should see whether this will be holding good or not. But then how many elements I am taking? I am only taking one integer. That one integer you have to put in the relation in both the sides. A. In both the sides you have to going to put the A. In the place of B also you are going to put A itself and see whether the relation is true on Z or not. So now I have for all A belonging to Z, I'll tell A minus A is equal to 2 into, what can I write? I'll write it as 0. That 0 also can be written as 2 into 0. So A minus B is divisible by 2. It is divides 2 divides A minus B, that's 2 divides 0 is true. Where? On Z, on our relation R. Therefore R is reflexive, and I'll call this as statement number 1. Okay, I'll repeat. For reflexive relation, we have to get into the set itself, which is our set. Our set is integers. For every integer whatever I take, I should check in the reflection for the operation they have given. What is the operation given? Operation is given that the subtraction is a multiple of 2. A minus B should be equal to 2 times M. So in the place of B also I shall put A minus A, which is equal to 0. 0 can be written as 2 into 0 on real numbers, which is true in real numbers. Okay, not exactly real numbers. We are using the set of integers Z, but my R indicates relation here. So on set of the integers, A minus A is equal to 0. 0 belongs to Z and that 0 can also be written as 2 into 0. It holds the relation. Okay, second one. Second one is symmetric relation. Symmetric relation, I shall take two numbers for all A comma B belonging to the relation R itself. Make it ulta and look into the operation whether it holds good or not. AB belongs to R. This implies that BA belongs to R. Okay, for all, let us see. For all AB belonging to R. You know the meaning of this property, the first part is already true inside the relation. So I'll go to my relation. I've taken A and B two elements and I'll apply the relation which is already true. What is the relation? A minus B is equal to 2m. So for all A comma B, A minus B is equal to 2 times m. I have applied the operation what they have defined already. Okay, but the relation is already done in whatever which is true. Now in arithmetic, I know that A minus B, if it is a multiple of 2, minus of that number also is a multiple of 2. I shall show you a numerical example. Okay, 4 minus 2 is equal to 2 is 2 times 1. Okay, or say 2m. Now I know that 2 minus 4 is minus 2 is also equal to 2m, is it not? Is it not 2 into m? So if I make it vice versa also, is still divisible by 2. 2 divides the sum number b minus a also. So I can write this implies minus of a minus b is also equal to 2m by arithmetic. Okay. Now I shall take this minus inside. This implies b minus a is equal to 2m. So from A minus B I came to B minus A. Because I came to B minus A, I can write B comma A belongs to the relation. So like this, for symmetric relation, you have to start from AB and you have to get in the process BA by doing this operation which is extra, that is doing from number theory in arithmetic, which is true. So I should get like this naturally. You cannot take, let the set be 2, 4, 6, 8. In that you take any two elements. 2 minus 4, 4 minus 2 also, you can't do that. So, whenever they say generalized statement like this, 2 divides A minus B, or A minus B is a multiple of 3 or multiple of 4 and things, you have to use the same procedure what we have done now. Now I will go to third property, transitive property or transitive relation. Okay, transitive relation, what does it say? It tells for all AB, BC belonging to R, this implies AC should belong to R. Okay, now according to this relation, already the first two, the true inside the relation. So I'll write for all AB, BC belonging to the relation R, and they are already true inside the relation, which is holding good to this. So I shall say A minus B is equal to 2m and B minus C is equal to say 2L, some L. Okay. So now in arithmetic, if I say 2 minus 4 is a multiple of 2 and 4 minus 8 is a multiple of 2, the addition of that also should be multiple of 2, which is very natural in numbers. Okay, it's a property. By property itself, it's like that. By numbers property. So I'll add these two statements. I'll say adding. I get LHS and LHS I'll add A minus B plus B minus C is equal to 2 into M plus L. Okay, this M plus L is some of the now minus B plus B got cancelled. What is remaining? A minus C is equal to sum 2K, M plus L, where K is equal to M plus L belongs to integers. Addition of two integers will give you another new integer. Similarly, here also you can write like that. Here you have 2m, m is a new integer there. Okay, a minus c is equal to 2k, where k is a integer which is the addition of two other integers m and n. A minus c. See, I started from a, b, b, c. I ended up getting a and c. So this implies that a comma c belongs to R. Okay, and this in turn implies R is transitive. This is statement number 3. What was your 2? Your 2 was, yes it is, see from AB I came to BA. So this implies that R is symmetric. Statement number 2. So R is reflexive, R is symmetric and R is transitive. Therefore R is an equivalence relation. So you can say 1, 2, 3 implies R is an equivalence relation. Okay. Now, in this question, they had not given you any set. Let A be equal to 1, 2, 3, 4 till 14 and so on. But there is a question where they have given the set A is equal to 1, 2, 3, 4 till 14. At that particular problem, you can either do this way in the same way, generalizing the terms, that for every two terms in the given set it happens like this, or for every two relation, what's that, ordered pairs in the from the relation is it is holding good. You can tell, you can continue with the generalized type, or in that set what they have given, you can write all the ordered pairs which is correspondingly given, obtainable from that whatever they have defined. You write the relation, and from that relation you can take the examples and do. That also holds good, provided they have given the set in the question by themselves. If they have not given the set as in this question, if they only give the statement like this, you are not supposed to take a numerical example by yourself. Okay, this is about reflexive relation, symmetric relation and transitive. When all the three are true for relation, we call it as an equivalence relation. And now children, for your JEE examination, one question on reflexivity from reflexive, symmetric and transitive will surely come. But that will be a fusion inside matrices, inside integration, inside functions, or they may give you any kind of sets and ask you to find out whether it is reflexive, symmetric, and it will have logarithm, it will have exponential functions. So these types of relations can be fused onto any other chapter. But one question is for sure in JEE. So understand the concept properly. Let's go to another question. I shall do some numerical examples and then come down to, okay. So now I am starting with example, with the exercise 1.1. Exercise 1.1. See here, question number 1. Determine if reflexive, symmetric and transitive. Okay, you need to, I have just taken the short forms, whether it is symmetric or not, you find out that telling. And there are 5 different questions, 5 sub questions. In the 5th question again there is 5 sub questions. Now I shall deal with each one of them so that the concept is very clear to you. Later on the theoretical problems I will lessen down, like I will do another maybe 3 or 4 theoretical problems, and the rest I will leave it to you. Okay. So now I am coming to sub question number 1. And I shall do all the problems which are repeatedly asked in the examination. I shall collect all the question paper questions and I will do for the class. The remaining questions I want you to try by yourself. You have relation R in A is equal to 1, 2, 3 till 14 defined as R equal to xy such that 3x minus y equal to 0. Okay, here goes your first question. Relation R in A is equal to. We are starting with this. They have given the relation 3x minus y. Whenever they give you the polynomials, it will neither be reflexive, nor be symmetric, nor be transitive. So how is it possible? So I'll go for the first one. Inside this I'll say the first one, reflexive. I should be choosing only one element, is it not? So I'll choose some 2. Let 2 belong to the set A. I'll repeat the same number in this relation. In the place of, so 3 into 2 minus 2, 4 minus 2, yes, it's the 6 minus 2 is equal to 4, not equal to 0. Therefore, R is not reflexive. Now like this, whenever you want to tell it is not reflexive, not symmetric, one counter example is sufficient. So next I'll say second one, we are going to symmetric property. Now let 2 comma 3 belong to R. Okay, I shall not take 2 comma 3, instead I'll say 1 comma 3 I'll take. let 1 comma 3 belong to R. So I'll do 3 into 1, in the place of x I am putting 1, in the place of y I am putting 3, which is equal to 0. Now this implies 3 comma 1 does not belong to R, because 3 into 3 minus 1 is not equal to 0. So this implies that R is not symmetric. It is not symmetric. Next I'll go to third one, transitive. Transitive. Now I'll take any two pairs. Okay. 1, 3. I'll take 3 comma 9. Okay. 1, 3, 3, 9 I'll take children. 1, 3, 3, 9 belong to R. It belongs to R. So I'll say, what is that? 3 ones are 3 minus y is 3 is equal to 0, and 3 comma 9. 3 into 3 minus 9 equal to 0. It's already true. So now for us, but 1 comma 9 does not belong to R, because 3 into 1 minus 9 is not equal to 0. Therefore, R is not transitive. Okay. So now for this particular example, I did it in a very detailed way so that you will particularly understand. Whenever they give you a polynomial like this 3x minus y equal to 0, it will not be any one of the properties, like any one of the relation. It will neither be reflexive, nor be symmetric, nor be transitive. So now we have R is not transitive, R is not symmetric, R is not reflexive also. Therefore, we have determined whether it is reflexive, symmetric or transitive. Now for this determination, when they say they give you only for 1 mark, directly when it's a polynomial, you can tell it is not, it is neither any one of them. And now I shall go for the second question in this main. In the first question, I am going to the second sub question. See, your second sub question, they are talking on natural numbers, and then tell R is equal to xy such that y is equal to x plus 5 and x is less than 4. Okay, x is less than 4, so my natural numbers will consist of what all numbers? 1, 2, 3. Whether it is 3 numbers only or whatever the numbers are, whenever they give you the linear polynomial, it is not possible. This is as good as y minus x is equal to 5. It is not possible at all. So, we will directly write, since y is equal to x plus 5 is a polynomial, R is neither reflexive nor symmetric nor transitive. Okay. So now I'll go to the third sub question. So that's about the polynomial. Next I'm going to R on A is equal to 1, 2, 3, 4, 5, 6. And they're telling R is equal to xy such that y is divisible by x. Okay, y should be divisible by x. So if y is divisible by x, if there is another way of doing whenever they give a set like this. I shall take all the pairs which will from the set A or from the Cartesian product A cross A, which will satisfy this condition. So let us write R is equal to, therefore R is equal to y is divisible by x. So I can take 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. It is y is divisible by x I have taken. Okay, next I'll take 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay. Next I'll take y should be divisible by x, is it not? Next I shall take this all this 2, 3, 4, 5 are divisible by 1. Next I'll take all the numbers which are divisible by 2. So I should say 2, 4, 2, 6. 2, 4, 2, 6. Next I'll take from 3. It is only 3, 6. That's it. We don't have any more. So y is divisible by x I have taken. See, whenever they give the numbers, whenever they give the set a equal to, you need to write a cross a, and all this should be inside your head. Mentally you should be able to have a vision of this and do the problem accordingly, or you should be able to count, tell it orally, then only you can do. So now we should not be writing like this actually, but I am showing you an example. So now I should show whether this R is reflexive. Is it reflexive? 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 6, 6 is possible, is it not? So for all, first one, for all A belonging to the set A comma A should belong to R. E is belonging to R. Therefore, R is reflexive. Belonging to R is true. Okay, so it is reflexive. Okay, second one. Now see, for all A comma B belonging to the relation R, A, B does not belong to R. I'll give you an example. Here, 1, 5 belongs to R, but 5 comma 1 does not belong to R. Therefore, R is, it is not symmetric. 2 divides 4, but 4 does not divide 2. Okay. Next, third. For all AB, BC belonging to R. Let us check out. I need not check for the reflection, so we'll leave it till here. 1, 2, 2, 4, 1, 4 is there. Again 1, 2, 2, 6, 1, 6 is there. Next I'll come to 1, 3, 1, 3, 3, 6, 1, 6 is there. 1, 4, okay, we don't have anything from 4. 1, 5, we don't have anything from 5. 2, 4, 2, 6, 3, 6. So you can see that it is transitive, is it not? So if y is divisible by x, e is divisible by, y is divisible by x, and then z is divisible by y. Therefore, x is divisible by, sorry, z is divisible by x is possible. AB, BC belonging to R, AC belongs to R, because if 1 divides 2, no, let me write like this. If 1 divides 2 and 2 divides 4, this implies 1 divides 4. Therefore, R is transitive. Therefore, R is transitive. So now this particular example, problem, we can see that R is reflexive and transitive, but it is not symmetric. So we'll go to the next question, and there is some interesting question in this. I shall leave one of them because with numericals I think you are understanding. I go to some statement problems where they talk about typical relations between the persons and places. See, I go to question number 5. In a town of human beings. Under that A, R is equal to xy such that x and y work at the same place. Okay, now this I shall tell you orally. X in the place of y also I will take x only. I should take one example. Sorry, one element, is it not? One element is one person. The same person I will put in the relation that's it and this and see whether it is true or not. X and x work at the same place. Yes, it is true. So reflexive. It is reflexive. Then symmetric. If x and y work at the same place, ulta, y and x also work in the same place. So it is symmetric. Transitive. X and Y work at the same place, Y and Z work at the same place, therefore X and Z work on the same place. It is transitive. So this is an equivalence relation. Therefore equivalence relation. Therefore it is equivalence relation. Next B I'll go. R is equal to XY such that X and Y live in same city, live in same locality. It is as good as this, is it not? It is ditto. It is reflexive also, symmetric also, transitive also, and it is an equivalence relation. C. R is equal to XY such that X is exactly 7 centimeter taller than Y. X is exactly 7 centimeter taller than Y. Okay. Now I shall tell some examples. I will do the problem. I shall write it very faster. Please understand. See, if see myself, I'm 5 feet. I cannot be more than 5 feet or less than 5 feet. I'm 5 feet only. So I cannot say I am myself taller, 7 centimeter taller than myself. It's not possible. So X is exactly 7 centimeter taller than X is false. So we write it is not reflexive. It is not reflexive. Okay. And next, what about X and Y? Now I am taking two different persons. So we saw reflexive not possible. For symmetric, I am taking two persons. So X is 7 centimeters taller than. So this is X and this is Y. I'm sorry. X is 7 centimeter taller than Y. Will the vice versa is true be? Will it be true? Y taller than X by 7 centimeter is impossible. So it is not symmetric. Okay. Next, if X is taller than X is 7 centimeter taller than Y and Y is 7 centimeter taller than Z, then is it true that X is 7 centimeters taller than Z? No, absolutely not. X is 14 centimeter taller than Z. So it is not transitive also. So it is neither reflexive nor symmetric nor transitive. And now in this particular question, had they not informed 7 centimeter, exactly 7 centimeter, if they simply say X is taller than Y, X cannot be taller than X, it will not be reflexive. If X is taller than Y, Y cannot be taller than X, so it is not symmetric, but it would be transitive. See, if X is taller than Y and Y is taller than Z, it is obvious that X is taller than Z. So, if they had not mentioned particularly 7 centimeter, then this relation would be true only for transitivity. So, I hope this question is clear for you. Okay. Other than this, there is, I'll take another one of them. I'll take E. R is equal to XY such that X is father of Y. X is father of Y. X cannot be father of X alone, X himself. So it is not reflexive. And if X is father of Y and then Y cannot be father of X, so it is not symmetric. And if X is father of Y and Y is father of Z, X cannot be father of Z. Instead, X will be grandfather of Z. So it is transitive. It is not transitive also. So it is neither reflexive, nor symmetric, nor transitive, even when you come particularly to this statement. So whatever the kind of relation they have given among the numbers or among a set of straight lines or among certain persons or some places, you can always create the relation and see whether they are reflexive, symmetric or transitive. And if it is all the three of this, then we call it as an equivalence relation. Now, these are the things that you have learnt in reflexivity and transitivity. For your question paper, question number 1 for few years, what they had asked is an example for reflection, symmetric and transitive. So, there is one question number 10 where you have to write the example, numerical example. No, they don't say particularly that numerical example. You can give any kind of example, maybe is perpendicular to or is parallel to. Let me tell you one more example. See, if they say is perpendicular to, we have one such question here. See, you have example 3. I shall explain this. Let L be set of straight lines, and R is equal to, I shall not complete the question, I will write directly, L1 comma L2 such that L1 is perpendicular to L2. Verify if it is symmetric, reflexive and transitive or not. Let us see. I'll go for the first one. The first one reflexive, second one symmetric, third transitive. Quickly let us finish. See, L1 cannot be perpendicular to itself. Therefore, it is not reflexive. And then if L1 is perpendicular to L2, this implies L2 is perpendicular to L1 is true. Yes or no? See, you have line number 1, line number 2, they are perpendicular to each other, which means what? L1 is perpendicular to L2, obviously L2 also is perpendicular to L1. So that is obviously true. So it is what? This is symmetric. It is not reflexive. It is symmetric. And what about transitive? What about transitive? L1 is perpendicular to L2 and L2 is perpendicular to L3. I should take 3 different lines. So I'll show you. L1 is perpendicular to L2 and L2 is perpendicular to L3. But how do you see L1 and L3 are? They are parallel, they are not perpendicular. L1 perpendicular to L2 is correct, L2 perpendicular to L3 is correct. But L1 and L3 are parallel, they are not perpendicular. So, where L1 is not perpendicular to, I will write but, L1 is not perpendicular to L3. So, this implies that it is not transitive. E is not transitive. So, E is perpendicular to, the relation E is perpendicular to on the set of straight lines is neither reflexive nor transitive, but it is only symmetric. But when you say E is an equivalence relation, which one is that? E is parallel to is an equivalence relation. So now I was getting into question number 10. I told you that it will be the question number 1 sometimes for your PU board question paper, where they'll say give an example of a relation which is reflexive but neither symmetric nor transitive, or they may say which is reflexive and symmetric but not transitive. So you should be writing an example. When you write an example, either you can go for some statement relations like this, E is perpendicular to or E is father of, E is sister of, or something like that, or maybe A less than or equal to B, A is congruent to B, something like that. Or the best way of giving the example is a small set of ordered pairs with 1 or 2 or 3 elements inside, numerical example. That's the best. So let us go to question number 10, where we have to give the examples. Yeah, here goes question number 10. Question number 10, give an example of a relation, not transitive. Okay, just now we saw one example like this. We want the relation should be symmetric, but it should be neither reflexive nor transitive. So, how do you do? Just now we saw, which is that E is perpendicular to. E is perpendicular to is, it is neither reflexive nor transitive, but it is symmetric. So, example 1 is perpendicular to on the set of straight lines. Is your fantastic example. But then if you can't do this, the best way of writing is the numerical example. Every time you say on A is equal to 1, 2, 3, R is equal to what I want it to be what? Only symmetric, it should not be reflexive. Now for this R to be reflexive, you should be writing 1, 1, 2, 2, 3, 3, all the three you have to write. For every element of the set A, you should have the reflections inside. So now what I'll do, I'll write only 1, 2 and I'll take 2, 1 and I'll stop there because I don't want it to be transitive also. See, it should not be transitive. If I write 1, 2, 2, 1, it is symmetric. And I don't have 1, 1, 2, 2, 3, 3, nothing, any one of them. So it is not reflexive. And it is not transitive because I don't have 1, 1. It is symmetric, but it is not transitive. For 1, 2, 2, 1, I should have 1, 1 for it to become transitive. It is not transitive. So this example is good for, is proper for being what? Only symmetric, but neither only symmetric, but neither reflexive nor transitive. Now let me go to the second one. They say like this, I'll use RST children. It should be transitive, but neither R nor S. It should not be reflexive, it should not be symmetric, but it should be only transitive. So now again I'll go to example 1 on A is equal to 1, 2, 3. 1, 2, 3. We'll say the relation R is equal to, it should be transitive, is it not? So I'll say 1, 2, 2, 1, 2, 1, 1, 1. And then I'll go for 2, 3. And it should not be symmetric, it should be transitive, is it not? 1, 2, 2, 3, I'll write 1, 3. Okay. So now see, 1, 2, 2, 3. For that I have 1, 3. For 1, 2, 2, 1, I have 1, 1. For 2, 1, 1, 3, I should have 2, 3. It should be transitive. Yeah. So I'll write, okay, 2, 1, 1, 3. I should have 2, 3. 2, 3 is already there. And then 2, 3. We don't have anything starting from 3. So transitive is okay. I'll check once again. For 1, 2, go for the starting ones, which is the 2. That is 2, 1. I should have 1, 1. I have 1, 1. 1, 2, 2, 3. I have 1, 3 over here. Next, I'll go for 2, 1 starting from 1. For 2, 1, you have 1, 2. Okay. For 2, 1, I have 1, 2. I need to have 2, 2. So I'll include 2, 2 here. This is how you have to adjust. You have to adjust so that it will be sounding proper for whatever they've asked. It should be transitive. So for 1, 2 and 2, 3, 1, 3 should be there. I have written that. For 2, 1 starting from 1, 1, 2, 2, 2 should be there. I have written that. 2, 1, 1, 3, I should have 2, 3. It's already there. So now it is transitive. So it is transitive and I should check whether it is reflexive or not. For being reflexive on this set, I should have 1, 1, 2, 2, 3, 3. I have 1, 1, I have 2, 2, but don't have 3, 3. So it is not reflexive. And it should not be symmetric. Okay. For 2, 3, I don't have 3, 2. So it is not symmetric. And hence I have written the proper example for which it is transitive but neither reflexive nor symmetric. Okay, this was example 1. I shall go for example 2. See, on say on Z, R is equal to A comma B such that A is less than B. A is less than B is a proper example for being only transitive but neither reflexive nor symmetric. I shall tell you an example. See, for this example, I shall say 2 is less than 2 is wrong. It is false. Okay, so it is not reflexive. Okay, and then 2 is less than 3, but 3 is not less than 2, so it is not symmetric. So it is not symmetric. Now what about transitive? 2 less than 3, 3 less than 4, 2 is less than 4. It is correct. It is transitive. So it is not R, it is not symmetric, but it is transitive. So For this kind of examples, you have to adjust with A is equal to 1, 2, 3 with number of pairs of ordered pairs like this, or you can go for some example which you already know. But generally you will not know, it will be difficult to write an example like this. So adjust it with the numericals. I shall go to another one of them like this, and you can try the rest by yourself. See, we have, I'll go for third one. They say it should be reflexive and symmetric but not transitive. But not transitive. It should be reflexive and it should be symmetric. So I'll say on A is equal to 1, 2, 3. I'll define my R is equal to, it should be reflexive. What is my first job? Take 1, 1, 2, 2, 3, 3. Okay. Next, it should be reflexive and it should be symmetric also. So I'll say some 2, 3, 3, 1. For that I'll write 2, 1. Oh no, it should be only what? It should be only symmetric. So I'll say 2, 3, 3, 2. But now it became transitive also. So I should take another pair. 2, 3. So now I'll say 1, 3, 3, 1. 1, 1 is there. For 2, 3, 3, 1, 2, 1 is not present. So it is not transitive. This is how you have to check. After you adjust, immediately you check whether it is holding good for your example or not. See, they are asking us that we have to give the example which is reflexive and it should be symmetric also, but it should not be transitive. For reflexivity, it is already reflexive because for all 1, 2, 3 I have written the reflections. Next, it should be symmetric. Let me check out. For 2, 3 you have 3, 2. For 1, 3 you have 3, 1. It is symmetric. And it is not transitive. I gave you an example. I'll repeat once again. See, for 2, 3, 3, 1, I don't have 2, 1 inside this. Therefore, it is not transitive. Hence, I have given an apt example which is reflexive and symmetric but not transitive. Okay. Now, these are the way you write the examples for reflexive, symmetric and transitivity. Now, I shall give you one numerical problem which was asked in the exam for only 1 mark. See, that was question number 6 and also question number 15. Question number 6 goes like this. Show that the relation are nor symmetric. It is neither reflexive nor symmetric. Now children, this example we already gave for the very first example in the question number 10. But still here you have to show, no? So I am writing here. So what is that? They have given A is equal to 1, 2, 3, the set is given. And R is equal to 1, 2, 2, 1. Okay. So now I shall write first one. The first one which is reflexive. For that I will write 2, 2 or say 1, 1 does not belong to R. Therefore, R is not reflexive. Now, this, whenever you have to write it is not reflexive or not symmetric, giving one counter example is sufficient, I told you. So, here you neither have 1, 1 nor 2, 2 nor 3, 3. Any one of them is not present. So, one of them you write and you write it is not reflexive. Second, what about symmetric? For symmetric, 1, 2, 2, 1. Okay, for AB belonging to R, this implies BA belongs to R. Therefore, R is symmetric. It is symmetric. Yes, we have to show it is symmetric. It is symmetric. Third, then we have to tell it is not transitive. So, how do I say? Is, and I think I have gone wrong something in the question. Is symmetric but neither reflexive nor, this is going to be, I'll check once, nor transitive. This is supposed to be not transitive, is it not? Transitive. So, now I am coming to transitive here. For transitivity, now I will say 1, 2, 2, 1 belongs to R, but the transitive relation 1, 1, but 1, 1 does not belong to R. Therefore, R is not transitive. So, we have proved. If they ask you to prove like this, you have to write if it is not symmetric or something, or if it is not reflexive, you have to write a counter example like this to show that it is not reflexive. There was one more numerical example, and that is an objective in your textbook. I shall do that and I shall stop with this relations. See, your question number 15 goes like this. Let R be equal to, I am cutting short the question, 1 2 2 2 1 1 4 4 1 3 3 3 3 2 on the set 1 2 3 4. Okay, choose the correct answer. That it is a mix of R is reflexive, symmetric, but not. Okay, I'll use like this. A is R is reflexive and symmetric, but not transitive. B, R is reflexive and transitive, but not symmetric. C, R is symmetric and transitive, but not reflexive. And D also they have given, R is an equivalence relation. Okay, which of the option is correct we have to find out. See, they have given 1 2 3 4 as the set, and for it has to be reflexive, then it should be option number 1 and option number 2 R is reflexive. We'll check like this. I should have 1 1 2 2 3 3 4 4. Do you have 1 1? Oh, 2 2 is there, and 3 3 is there, 4 4. So it is reflexive. So if it is reflexive, then it should be A or B or D also, because equivalence. Next, I'll go for symmetric. For symmetric, what? If you have A, B, B also should be inside the relation. Only I'll check it out. See, 1 2 belongs, but 2 1 does not belong to. So we'll write 1 comma 2 belongs to R, but 2 1 does not belong to R. Therefore, R is not symmetric, which means that is symmetric, A is not the answer, and equivalence is not the answer, and it is reflexive, is it not? It is reflexive. So, but here they are given but not reflexive. This is not the answer. So, obviously B option is the answer. So, for checking out from the option to show how to recognize the answer, I did like this. And now with this, I shall stop with reflections. With relations. And in relations chapter, I should tell you some 2 or 3 kinds of relations where you have like empty relation, universal relation, and identity relation, antisymmetric relation. These 4 types, and also some examples where I have to tell you. For JEE examination. That much I'll tell, and then get into the kinds of functions. What is a function? How this relation will become a function, and types of functions in the next class. And I would like to tell you very clearly that this is some concept which will be fused into the other chapters. So please understand the concept properly. And if it has been boring or something, don't stop at that. Please redo the videos and see that you will learn the concept properly. Because doing the revision for this chapter will be difficult because it's entirely theoretical. Okay, so we'll go to types of little extension of relations in the next class. Thank you.